Hello, welcome everybody to today's talk about how to get most out of the Squish IDE. I'll be covering a couple of different topics involving the Squish IDE. I'm starting out with configuration, going from there to different ways of navigating between user interface elements like views and editors. Then I'll demonstrate a couple of helpers when working with script code, and finally we'll come to look at some debugging helpers. Starting out with a very fresh setup, no previous configuration has happened in my Squish IDE. I only opened an example test suite so far, which you can see in the test suite dropdown. The first thing I always do in my IDE is close views that I don't use and hide views that I don't use very often. So for example, the test summary view, I don't use that very often at all, if at all. The test description is also something that I don't use myself very often. And finally, the global scripts view. I do use that every once in a while, but not very often, so I'd like to take advantage of the space it covers by hiding it to the side. I also do want to see one more view that we don't open by default, which is the problems view. The nice thing about the problems view is that it shows all kinds of script errors that happen in the test scripts in a single place. So the main point here is close the views that you don't use, hide the ones that you use only sometimes, and add any views that you find useful or necessary for your everyday work. This leaves you a lot more space for the important parts. Now, having those three views down here, I also often want to see the runner server log and the test results at the same time. And with a wide screen, like in this case, it's possible to do so by just drag and dropping the runner server log tab to the side, and this will make the IDE split the area between the two views. The same is possible for other areas, like the vertical one on the left, if you want to do that. You can also move views completely to the area by drag and dropping the tab directly to another tab. This functionality also exists for editors, so opening up two different files, in this case a feature file and the corresponding steps file. It makes sense to have these open side by side. The idea being that I want to work on the steps implementation, but also have an overview over the actual scenario or scenarios that are available in my feature file. So again, drag and dropping the editor tab to the side, I can have both editors open at the same time and work in one editor on the right side, while still having a view onto the main feature file on the other side. Besides these user interface configurations, you can also configure a lot of behavior of the IDE. This is done through the preferences dialog. The IDE is based on Eclipse, so a lot of the preferences provided here are coming from Eclipse itself. For example, the appearance that you can change. One interesting thing for people using other files than the test scripts in their test suites is the file association. However, many people that do use XLS files on an everyday basis do also have the corresponding editors for that. So for example, I can say that I want to open these files with LibreOffice. And then double-clicking an XLS file in the IDE's test suites view will open LibreOffice instead of the internal test data editor. Talking about files, the script files and their corresponding editors can also be configured in a variety of ways. For example, you can select what kinds of errors or warnings you want to see. In this case, this is a JavaScript editor. You can also decide how to format script code when you use the corresponding format function from the menu. This also affects recorded script code. So whenever Squish records a snippet for your user interactions in the AUT, it will use the formatting information from this configuration to format those snippets. And finally, we have the Squish area. Here you can select a couple of different IDE-specific configurations for Squish. For example, if you want to see the object not found, image not found, or text not found debug dialogues, or maybe you don't want to show the control bar but rather have the IDE window visible when you execute your tests. There are many more configurations possible, and I encourage everybody to play around with them, try to figure out what they do, and we are always there to help understand what they do if you cannot find it out yourself. One major point that leads us to the next sections and is very important for the next couple of sections, the keys. This page allows you to configure what keyboard shortcuts are available in the IDE and also view what actions you actually have available, because not everything is always available in menus and context menus. For example, executing a test case has a shortcut associated with it. We can see the action here, run test case, called Ctrl R. So executing a test case can be done by pressing Ctrl and R on the keyboard anywhere in any window, as the when column says. You can also export these informations into a CSV file and this way create a cheat sheet for yourself to memorize those keyboard shortcuts. With that, we are done with the configuration, and I'm going to close the editors and look next thing into navigation between user interface elements. So how do I get from the test suites view to the test results to the active editor and so on? The first navigational helper is the quick access line edit that you can find in the upper right corner and can be accessed either by clicking it with the mouse or by pressing the Ctrl+3 shortcut. And the line edit tries to match whatever you type into it against actions and views and editors in the IDE. So for example, typing result, I can select the test results view and that one will be made active, which you can see by the tab being completely white now. Similarly, I can open editors and go to the quick access and then type parts of the editor title, for example add, to go to the corresponding editor, and it will activate that. Now the quick access is something that was introduced with the Eclipse 4 version, and also before that you already had ways to access different parts of the UI, so they were just not unified like this. For example, you can press Alt-Shift-Q to open up a pop-up on the bottom right, which gives you a list of all the shortcuts associated to a particular view. So I can now select, for example, the problems view to get to that. I can also press Alt-Shift-Q and followed by B to immediately open the breakpoints view. You can configure these shortcuts again in the Preferences dialog. Closing these two again. In order to switch between editors, you could use the quick access, but again, in earlier versions of Eclipse, different ways had to be used. For example, you can get a list of editors and editor windows up with the shortcut Ctrl F6, and this allows you to basically tab through the list of open editors forward and also backward, which is not very visible with just two entries, but pressing Ctrl Shift F6 moves you backwards to the list and Ctrl F6 forwards. In a similar way, you can navigate between different views by using Ctrl F7 and Ctrl Shift F7. This opens up the list of currently open views, including the editor area, and allows you to easily switch to something like the global scripts view. And now I could use again keyboard navigation to move myself around here and open different global files. Let's close the editors again. No, don't want to save that. Having talked about editors and how to switch between them, there's a different way to navigate to other places in your code. This somewhat touches on the next section, working with script code, but I'd like to demonstrate this here because we also see something related to this that very much relates to navigation itself. So I have this test script which uses a shared function called verify entry, and I'd like to verify or look at what this function does, which can be done with a keyboard shortcut or with a menu entry called go to definition. As you can see, the keyboard shortcut is F3, so let's use that. And this brings me to the script file where the function is defined. And this one also uses a function called cellName, which I'd also looked at, but in this case it's in the same file, so that's fine. So this is a huge helper when you want to understand how some particular piece of code works. Now, the thing I actually wanted to show with this as well is the navigation history. You can see that in the toolbar here, but it's also available as a keyboard shortcut again. And this makes it very easy to look into some piece of code that you stumble upon, understand how it works, and then go back to the place where you've been to continue reading or working. So I can now press Alt left on my keyboard and jump back to the place where I was before. And I can do that again to jump to the verify entry function definition, and again to go back to the place where it's been called. This is the navigation history, and since we're now in the script editor anyway, let's move on to the working with script code section. The first thing I want to show is how to open files. So far I mostly use the mouse to open new files from my test suite, but in everyday life I don't use the mouse that much. Instead, I'm using keyboard shortcuts again. In the Squish IDE, you can use Ctrl-Shift-R to open up a dialog which allows you to again type parts of a file name or parts of the path of a file name and get a list of filtered files in all your test suites. So in this example, I could say that I want to open a test.py file, which is going to be a little too much for me to navigate through. So I have to refine my search, and one way to do that would be adding parts of the path to it. So for example, I can say add, and this will open up the test.py related to the tst add data test script. So let's do that, and now I end up in this editor. The open resource can also open up globally shared scripts or files that are not script files, so it really has access to all the files that are in your test suite. In this file we have two functions. One is the main function and the other one is the invoke menu item function, and in many cases you will have more than those, and in order to navigate between those there's a helper called quick outline. This I triggered with the Ctrl-O shortcut, and it has a list of the functions that are in the file, of all the classes and their corresponding functions, so you can easily move to a different place in the same file. Very useful for larger files. While being in this file, I noticed that we have an object name here called table_object, which I don't really like. It doesn't match the other names we have below, like for name line edit, so I'd like to rename that. And this renaming functionality for scripted object names works in all script languages, not just Python. Through the refactoring menu usually. It also has a shortcut, so it's very easy to rename object names without even using the mouse. But in this case I'm going to. This brings up a dialog where I can type my new name. So let's call this main table widget, because it's actually a table widget. And then I can preview the changes, and as you can see, it renames all the occurrences of this particular object names in all my files. And once it's done, I can still decide that it didn't do the right thing and use the undo button to undo the whole thing. The next thing I'd like to show is related to refactorings. It's extracting a method from a piece of script code. In order to do that, I can select a couple of lines of script code that I'd like to move into a separate function. For example, because I intend to reuse this piece of code more often in other test scripts. In this particular example, these lines of code add a new entry to our address book example. And this is something that happens quite a lot in different tests, and so I'd like to have a shared function for that. Extracting these lines of code into a method can again be done through the refactoring menu. It also has a keyboard shortcut if you want to do that. And the nice thing about the helper, the wizard, is that it will take up all the local variables and make them arguments to your function. So I just have to decide on a name, for example, add entry. And the extract method helper will already take care of making the local variables into arguments and using those arguments. I could even change their order if I want to. And as you can see, it took the script code that was inline in the main function and moved it towards the top of it into a separate function and replaced the script lines with a single invocation of the new addEntry function. So finishing that, I get a different script code, and I can now easily move this bit of function, the addEntry function, into a shared script. As before with the rename and refactoring, I can also undo this. That's about everything I wanted to demonstrate with script code. So the next thing would be debugging helpers. I'll close the test scripts here, and the first debugging helper I'd like to demonstrate is the spy. Now, I suppose many of you already know about the spy in general. We have the application objects view on the left side, and we have the properties, methods, and the runner server log on the right side, which are the main elements to work with when you're spying your application. Something that we added a few versions back is filtering. And I'm mentioning this because it makes it very easy to get to particular objects based on their name in a larger hierarchy or larger list of objects, because our address book is quite simple, but real-world applications usually have a lot of objects. So the filtering works relatively easy. It's completely case insensitive and allows for wildcarding. So I can say add, and we'll find the add queue action. I can also say remove and find the remove queue action. The reason why I expanded the address book item first is that this doesn't work recursively. So it only filters what you currently see when you have no filter. This is mostly for performance reasons. The same filtering applies to the properties view. So again, I can expand, for example, the font and then say search for pix, and I will end up with the pixel size. Going back to a more interesting widget, like the main window, I can also search for width and find different width. I can say I'd like to find the minimum width, so I can say minimum, min for minimum, and then star as a wildcard, and then WID for width. This may seem like a very minor feature, but according to our support colleagues, this is a huge helper when trying to determine whether some property is there or finding some particular property that you know should be there, and you don't have to scroll through endless lists of properties. The second debugging helper I'd like to demonstrate is the script console. I have a test case prepared here that I'm going to execute, and this test case is going to run into an object not found error. Now, since this particular test case doesn't use a symbolic name, we cannot pick a new object and update the name in the object map. Instead, I'll have to debug this myself. I don't need the object map right now because, as I said, we don't have a symbolic name for this anyway, but what I'd like to have is the object name in the clipboard, because that's the problem. And the script console will help me figure out why this particular object name doesn't work, and it does so without breaking the test script. So I'm first going to make this bigger for everybody to see by double-clicking the tab. And in order to get the error message again, I'm just going to execute find object with the object name. The benefit of this is that I don't need to wait for 20 seconds for it to fail. So I see here we have a lookup error with the window object from the tool button, and the window object doesn't match the title. Now, going to our address book example, we can see indeed the title is not unnamed. Untitled, sorry. So let's adjust the object name by copying the original script line and then removing the title. As you can see, this now doesn't generate an error. It returns an empty string because that's how the Q button looks like when turned into a string. Going back to my test script, one more thing that is useful in the script console, I can access all the variables that are currently in scope. So for example, I can check how much memory does the context use. So that's about 50 megabytes right now. I can also run other script code. I can even run invalid script code. I will get an invalid syntax error, but the test script won't stop. So whenever you're at the breakpoint, in this case, continue to running doesn't make much sense because I cannot update the test script currently for technical reasons again, and have the test execution see that update. But you can set breakpoints and look at your local variables, try to call functions that are going to be called and end up doing something wrong. And so experiment with your script code before writing it down and having to start the test case all over again. This is a very nice method for easily trying out small changes to script code. The final debugging helper I'd like to present is related to running your tests in CI or some other kind of automated test execution. It's about importing and exporting results. I have prepared a test result that is from running the TST importing results test case, but was executed on a different system. And I'm going to import this into my current IDE that is running on Windows. So I have this zip file that I exported from a different IDE on a Mac. And as you can see, it already loaded all the test results, but it's also asking me, where is your test suite? Since the original execution was on a Mac, the path doesn't really match what I have now on this system. So I need to adapt that. And on this system, the path is slightly different. Ooh. And once I have the right path, I can also, of course, use the browse button. Once I have the right path, I can click OK, and the IDE will be able to match this path from my Mac system to the local test script and local imported test suite. And it will navigate to the first verification failure. The same applies to the second verification failure. So I can easily jump to the corresponding lines and investigate what exactly happened here, why did it fail. In addition to that, the test report also contains all the artifacts related to the test execution. So it contains desktop screenshots that were done on a failure, for example, and I could view them. It also contains the actual images from screenshot verification, so I can say view differences. And again, need to adjust this path a little bit. And once the path matches, I can now get the screenshot verification diff viewer and see the differences between the test executions. Now, the difference here is just highlighting. I could say, okay, accept the change and continue, and then run the whole test suite in automation again, automated way, and the test result would be fine. This importing and exporting is also being extended to a new product or addition to Squish that is coming up called Test Center. And the IDE, of course, has support for that as well. So it allows you to view the test reports that are in a Test Center instance, and you can easily download them and view them inside the IDE in basically the same way that I now use the import mechanism. That's all I wanted to show today. Thanks for your attention.